Okay, so for our second problem for rectangles, our sixth lesson in the second quarter for geometry, let's try this problem. BQRS is a rectangle in which BQ is twice as long as QR, and T is a point such that the shortest distance of T from BQ is square root of 3 times the length of QR. Okay, and given that BT is equal to QT, and if M is the midpoint of QT, what is the measurement of angle RM? This is the angle that we want to find for this given. So how do we solve for the measurement of this angle? That's the essential question, the main question in this problem. Okay, so if this is a line, and this distance is the shortest distance between BQ and C. Therefore, these two lines must be perpendicular to each other. So therefore, this is a 90-degree angle. And this 2x that we have here is going to be bisected into x and x as well. Okay, so that is our side measurement. X is the short side measurement that we are trying to find. We're trying to find from this problem. Okay, so if that's x and if that's x, we can also say that for this problem, it says here that T is such a point that the shortest distance from T from BQ is square root of 3 times the length of QR. Now QR is x. We don't know the value of this figure. It says here it's twice as long. BQ is twice as long as QR. So that's why we denoted QR as the value of this full problem. So therefore, if QR is equal to x, so this must be x squared. If you're going to recall the formula for the special right triangles, specifically for the 30, 60, 90 right triangle, the formula goes out like this. It's x squared of 3, and 2x. Now that we know that the value of this right triangle has a side, the value of the side of this right triangle is x, and x squared of 3. So therefore, TQ here must be 2x. And since TQ or QT is equal to BT, so therefore this is also 2x. So therefore, what type of triangle do we have here? Triangle BQT has sides 2x, 2x, and 2x. Therefore, it's an equilateral. It's an equilateral and an equiangular triangle. Now, if it's an equilateral and an equiangular triangle, therefore the side measurements of these, the angle measurements of these vertices are 60, 60, and 60. Okay, and if this is 60 degrees, the angle adjacent to it, okay, or the complement of 60, so that's going to give us 30 degrees, right? So that's 30 degrees. Now, it says here that if M is the midpoint of QT, now this is line segment QT. If M is its midpoint and the measurement of QT is equal to x, therefore the measurement of Q1 is equal to x, and the measurement of MT is also going to be equal to x, right? So that means this is x as well, and this is x as well. Now we know that this is x. So therefore, what type of triangle have we formed here? What type of triangle is triangle QR? So it turns out QFR is an isosceles triangle. Now, if it's an isosceles triangle, therefore, its two angles should be the same. So therefore, the measurement of angle M should be equal to the measurement of angle R. Now, for this problem, we already know the value of one angle, so that's 30 degrees. To solve for the other two angles, so that's going to give us 180 minus 30 is equal to 2 times x, which is the value. Maybe let's try to use a different letter so not to confuse. Let's use letter y. Y being the measurement of angle RMQ or QM. Okay, so that's going to give us 150 is equal to 8. And if we divide both sides by 2, so therefore the value of y is just equals. Okay. So therefore, the measurement of angle RMQ, measurement of this angle here, so that's equal to 75 degrees, which is the same as angle R, which is 75 degrees, letter T. And that's the answer for our question number 2. See you guys next time for our next questions or next topics in the second